Are you ready to learn how to apply security to the most popular DevOps tools? DevSecOps is all about that. It's an approach to culture, automation, and platform design that integrates security as a shared responsibility throughout the entire IT lifecycle. It includes secrets management, analyzing vulnerabilities, monitoring your application for malicious activity, and many more. So this course is a complete guide on implementing the best security practices and tools on your DevOps frameworks. And this course is created for both beginners and experienced professionals. For that reason, we will start with the very basics by exploring the DevOps architecture and how it is related with the DevSecOps. You will learn how to secure the two main container management platforms, Docker and Kubernetes. You will master container management, how to work with Docker files, getting and building your own container images and optimizing them. Then you will master progressively the implementation of the extra security layer to your DevOps tools. It is a great time to learn DevSecOps, so I'm looking forward to see you in this course. I'm uploading completely free programming courses every week, so make sure you hit the subscribe button to get more coding skills. In the past 10 years, DevOps became one of the key tools for building efficiently and quickly any type of software. And the two main tools that are used into the DevOps are Docker and Kubernetes. Docker is used to build microservices into containers, while Kubernetes is used to take multiple clusters of containers and running them simultaneously. However, in the past years as well, those two tools became one of the primary target for the hackers and the online attackers. This is because if you can break into those, you can actually break into the applications of the entire company. So for that reason, the term DevSecOps appeared, where sec comes for security. This is basically the way in which you can actually secure your DevOps applications. So that course will be all about that. We will talk how you can apply the key security principles to secure your DevOps application, and we will cover many of those. I will teach you how you can secure your Docker host, networks, containers, images, while at the same time you learn how to secure the Kubernetes clusters, nodes, pods. We will cover all of those terms and you will see how you can apply security since the beginning of the DevOps lifecycle. Hi everyone! In this section, we're going to talk about the DevOps architecture for the enterprise. So before learning the DevSecOps, it is going to be quite beneficial for you, firstly to learn the DevOps architecture, which is what you're going to be doing in this section, and then moving to everything related to DevSecOps. So in this section, we're going to cover a brief introduction to the DevOps in IT delivery, creating reference architecture, introducing DevOps to the companies, and working with the voice model. But let's start with the introduction. So since this course is going to be focused on implementing DevOps on large-scale companies, so we cover all the cases. And so before we go to the specific challenges for the DevOps and DevSecOps, we need to first have a common understanding for what DevOps is. So basically, DevOps is the development and operation stages working as one team. And this team builds a product and then runs it. It is that simple. So the DevOps has gained a lot of momentum over the past decade, essentially in enterprises. But actually implementing the DevOps is a difficult part. The reason for this is that enterprises are not organized in a structure that works for DevOps. This is because in the last century, most enterprises outsourced a lot of their IT. And for that reason, DevOps becomes way more difficult when development is done in-house while the operations are outsourced. So by bringing the teams together into development and operations environment, the enterprise can speed up the delivery and release new products and services. And in that way, less handovers are needed between the development and the operations. In that way, the quality of the product will improve since DevOps already includes quality assurance, testing, and security. So here I bring in front of you some of the key benefits for DevOps. The first one is that DevOps brings the business, the development, and the operations together into one properly working system. On the other hand, enterprises having DevOps can respond faster to demands from the market because they're absorbing continuous feedback from their work. In the same way, products are continuously improved and upgraded with new features, instead of planning major next releases and wasting a ton of time to create a complete new project and outsource it. And finally, through the automation and the DevOps pipelines, enterprises can really reduce the costs in terms of both development and operations, and at the same time improve the quality of their products. And when building DevOps, the first and the main starting point is the enterprise architecture. This is where the business goals are set and we define how those goals are met. So the IT delivery is key to meeting those goals. So in large companies, the architecture also defines the IT delivery process, and we will specifically look at the IT delivery and its processes in more detail. So as I already mentioned, the enterprises typically have operating model that is based on outsourcing. This makes implementing DevOps more complicated. Normally, the enterprise architect will have to have a very clear view of the connection between the different processes and who is responsible for fulfilling those processes. Basically, who is responsible for what, when, and why. And the next question would be how this can be converted to DevOps. So before that, we first need to understand what are the main processes in IT delivery. And I actually bring here in front of you all of those processes, and let's talk a little bit about them. So first, let's start with the business demand. This pretty much covers what are the business needs and understanding on what the requirements are for the product that is being developed. Those requirements are normally set up by the people that are going to use the product or the clients. So customers will demand product that meets specific functionality and quality. So the architecture must focus on the delivery and the end-to-end product to satisfy the requirements that were defined initially. So in DevOps, an assigned product owner makes sure that the product meets those requirements. The product owner will have to work closely with the software designer. And then we move to the next process, which is the business planning. So once the demand is clear, the product needs to be scoped. In DevOps, the product teams typically start with the minimum viable product. So the first iteration of the product that does meet the requirements of the customers is actually called the minimum viable product. So when designing this product, the processes need to be able to support the development and the operation of the product. So the business planning involves the quality management and testing that are two of the major components on the IT delivery. Then it comes the development process. And in DevOps, the product team will work with user stories. A team must break down the product into components that can be defined as deliverables. To do this, we should have clear definition of the user story. And so the user story always have the same format. So any user story need to have an acceptance criteria or the definition of done or DOD. And once the product is developed, then we can talk about deployment. At this stage, the code is tested, validated, and it matches the user stories. And so now it can be deployed into the production state. So the testing and the releasing of the product is normally automated in the pipeline, so that should be easy once set up at once. So before the code is actually pushed to the production, it also needs to be merged with the configuration. You need to think about the security packages that need to be applied to components that can run into production. So at the test and the quality process, the full package consisting of application code and infrastructure components needs to be validated and be ready for production. So the result after the deployment stage, it should be a live product that is ready to use. So when you're performing testing, if bugs or violations to security are discovered, the product needs to be set back to the earlier stage or to the development. And finally, once the product is deployed, then we move to the final process, which is operations. So after deployment, the live product of course needs to be operated. To do this, enterprises work according to the IT service management principles. In fact, the operators are in the same team as developers, but this doesn't mean that the IT service management principles are not valid anymore. For example, when incidents occur, the incident management process should be immediately triggered. So during operations, they could be looking for requirements fulfillment, incident management, problem management, and so on. So with all those delivery components for the IT process, DevOps actually adds the continuous integration and the continuous delivery, or the CI/CD. You might heard about it, and this is one of the most important concepts when talking about DevOps and pipelines. So let's talk about this. Let's first talk about what is continuous integration. So continuous integration, or CI, is built on the principle for shared repository where the code is frequently updated and it is shared across all the teams that work into a cloud environment. The continuous integration allows developers to work together on the same code at the same time. And so changes into that code are directly integrated and ready to be fully tested in different test environments. On the other side, the continuous delivery is the automated transfer of software to test environments. So the ultimate goal of the continuous delivery is to bring software to production in a fully automated way. So all the various of the test cases should be performed automatically. So after development, the developers should immediately receive feedback on the functionality of their code. And so due to that, the CI/CD requires a feedback loop, and this is why we say it to be continuous. It needs feedback about the delivered products and services. And so this is then looped back to the developers, and from there, new interactions are planned to improve the product or the service. So this works quite well if a single enterprise controls the full cycle and no processes are outsourced to another organizations. However, for many big enterprises, this is impossible, so they have to outsource. However, sometimes activities are not perceived as core activity, and some companies decide to be more cost efficient and to delegate that to somebody else. However, in the past decade, all those organizations have been through a massive change. The IT departments have become more and more important, and in some cases, the software development has become a core activity. And a good example for that are actually the banks. So all the banks are actually IT companies in these days. So the output of their IT delivery are the financial products. So due to the customer demands, releases of those products with new features have become more frequent, and they take sometimes several releases a day. So let's talk a little bit about delivery in a sourcing model. And you can see this on the graph in front of you. So sometimes sourcing can be quite complicated, but if we learn to think in terms of sourcing tires that you can see right here in front of you, it becomes way more comprehensive and easy to understand. So using this model, we can break the IT delivery into three main phases or tires. The first one is the strategic tire, or the strategic level, and this is the tire for the enterprise governance. The enterprise defines strategic business goals that are translated to enterprise architecture. So the overall architecture principles are the outcomes of the enterprise architecture and drive all IT architecture, including the DevOps. Then in Tier 2, or the tactical level, is where the IT architecture is developed, including the DevOps. So here is where the service level agreements and the key performance indicators are defined to measure the outcomes of the IT delivery. And finally, the final tier, which is Tier 3, it's called operational or services level. At this tier, the components of the architecture are detailed, including the interfaces to various suppliers and service providers. So the agreements that were defined in Tier 2 should be adopted at this level so that all work that's been done for the development and operations is done in the same way. So in practice, the service providers are normally acting on Tier 2 if they're involved in larger programs spinning on multiple products. So at this tier, the provider is responsible for aligning the different streams in the lower tier or tier 1. So here is how the sourcing models are looking like, guys. Hi everyone and welcome back to the course. In this video, we will talk about how you can create a reference architecture integrated with the DevOps. In the previous video, we were looking at the different processes of the IT delivery and how it is integrated into the DevOps. So any DevOps architecture will have to address planning, development, integration, deployment, and operations. But we have to keep in mind why we're doing DevOps. And this is to achieve the business goals in a faster, more agile way and to continuously improve products. The DevOps architecture doesn't stand on its own. It has to be linked to an enterprise architecture. To do that, we're normally using the Open Group architecture framework designed with architecture development method to draft architecture. And this is what you can see in front of you. In the figure right here, you can see the architecture development method. So just like the DevOps, the architecture development method is a cycle, except in the very first phase, which is where the need for architecture is formed. This has to be done in tier 1 in the sourcing model that we discussed in the previous video, and the core of the architecture development methodology is a sequence of architecture design which is business first and setting the principles and the requirements for the actual solution. Those principles drive the architecture data usage, the applications, and finally the technology that will be used. This is important because architecture is not about technology in the first place. Technology is purely the ability to achieve business goals in the enterprise level. So the architecture developing method assumes that the architecture is not static. It changes as soon as the business requirements change too. If the business demands change, there will likely be a need to adapt to the architecture in the future solutions. So, as we discussed in the previous video, there were 3 tiers, and in tier 1 is where the goals are set for the entire enterprise. In the next level, in tier 2, is where the DevOps teams will translate the goals into product features and start developing the product. DevOps teams will have to work according a set of principles. So let's take a closer look at those principles. So in fact, there are actually 6 DevOps agile skills principles, and those are very first the customer-centric action, which is to develop an application with the customer in mind, what they need and what does the customer expect in terms of functionality. There is also the goal of another concept, domain-driven design, which contains good practices and ideas. Then, when you build a project, you always need to have the end result in mind, or how will the product look when it is completely finished. With the end-to-end product in mind, it comes the end-to-end responsibility. And here the teams need to be motivated and enabled to take responsibility from the start to the finish of the product lifecycle. Principles such as you build it, you run it, you break it, and you fix it is one of the key principles for taking responsibility. Then we need a cross-functional automation teams. They need to be able to make decisions themselves in the development process. Then, as we talked in the previous video, a continuous improvement is quite important for every project, and we need to continuously improve our product. And finally, in order for our project to be very efficient, the goal of the teams should be to always automate as much as possible. The only way to regain speed in delivering and deploying is by automating as much as possible. Automation also limits the occurrence of failures and bugs in your code. So based on these principles, they're leading to some architecture statements that are the core of the DevOps. Those principles are automation, which is basically responsible for automating everything. With automation, the amount of time between testing and deployment will be significantly reduced, enabling a faster release process. But on the other hand, automation will also lead to way less manual interaction and therefore less errors. The next architecture statement is collaboration. So you remember two of the 6 principles are cross-functional automation and end-to-end responsibility. This can be only achieved by a very good collaboration. Development and operations will have to work very closely together to speed up the delivery and the releases. Although this is also a cultural change, collaboration requires common toolset that supplies that collaboration. So automation also requires a clear portfolio that contains building blocks that can be automated easily. These building blocks are called artifacts in the ADM cycle, and they represent packages of functionality that can be used to fulfill requirements. Some of the most famous tools for keeping artifacts are, for example, Artifactory. The building block is reusable and replaceable, and therefore it must be clearly specified and defined. So the configuration of the building blocks needs to be well documented and brought under control of the configuration management. If this is done well, those building blocks will also have clear interfaces so that they can be fully automated. And finally, let's talk about integration, which is where the development and the operations come together. In DevOps, we integrate the business demands and the IT delivery user stories. Code is normally integrated with new functionality that is coming out of the business demand. The demand is changing faster those days, so development needs to keep in mind the continuous integration. This will lead to changes that adopt new development at some very good speed. So the final step to merge the DevOps principles into one model for our reference architecture is to build the reference architecture model. So the model contains two main cycles, and as you can see from the figure, there is outer cycle, which is right here, and also there is an inner cycle. So the outer cycle is the product cycle, while the inner cycle represents the operational activities. And so as a logical consequence, the outer cycle is governed by the enterprise itself. The inner cycle is about actually delivering the product using DevOps. And as you can see, there are interfaces between the outer and the inner cycles. And those are collaboration, automation, integration, configuration management, and the interface layer. So in the outer cycle, the business goals are translated into architecture. From the architecture, a portfolio is created with business blocks to create products and services. Products are released to the market and adopted, but due to changing demands, there will be requests for changes. So those changes will drive new enterprise planning and some change into the business goals. So in that way, the business will continuously absorb the change in demands. So the plans and the actual builds are expected to be executed into the inner circle, as you can see here. In this circle, the product is broken down into product backlog items that will be developed and eventually operated by the DevOps teams. These teams do not operate by themselves, but they are triggered from the outer cycle. So this is why we need the interface layer. This is the interface between the business and the execution teams doing the IT delivery. So there is a collaboration between the architecture and development. And as we mentioned before, the releases should be automated as much as possible. And so requests and changes should be integrated with the planning on the backlog of the DevOps teams. And so the builds are pushed to production, and those ones that are actually pushed, they need to be monitored and brought under control from the configuration management. So let's see how this would actually work in practice by the next figure. So here you have some people within the model that you saw in the previous slide. And this is basically the DevOps workflow for enterprises. So you can see that from the enterprise, we're getting the business plan, and then this is passed to the business unit. From there, it goes to the product owner, which distributes the work to the different teams. On the other hand, the enterprise architect works with the security officer to build the enterprise architecture that translates into portfolio that builds a roadmap. From there, we can actually trigger the DevOps cycle where we create a product, architecture and backlog, and we're running continuously everything on pipeline in order to implement every new change and have a continuous development and integration. So I hope that from this video, guys, you really got a good introduction on how DevOps is implemented into IT delivery. Hi everyone, and welcome back to the course. So far we learned how to start defining the architecture, looking at the architectural principles of the DevOps, and drafting the reference architecture model. So the next step is to look at the different components within the DevOps. So in this video, we'll learn what components must be included into the DevOps architecture. And this is actually the tier tree from our tiers figure of the target enterprise model. And this is the level where all activities should be executed. So here in front of you, you can see the agile infrastructure, and the reason that this looks as infinite loop is because feedback from the live product that is managed by operations will continuously be looked back to develop and improve the product. And this is from where the DevOps comes. Dev from development and Ops from operations. So as you can see here, the different components are planning, creating, testing or verification, then preparing, releasing, configuring, and finally monitoring. And from the monitoring, if we see that we need certain improvement, then we jump back to the plan station. So remember that at large enterprises, you will likely work with several service providers that are fulfilling parts of the IT delivery process. So when we want all of these components to work together in a DevOps way, we need to make sure that the process and the tools are aligned. And so the next thing is to have common understanding for the various activities that are executed as part of these principles. And so all DevOps components must be defined and implemented in a consistent way. Every developer and operator should work accordingly to the same definition and within the same components. And so from here you might have the question, at what stage the DevOps should be developed? And the answer to that question is as early as possible. The operations play a key role in defining new products and bringing them to life. They should set the requirements and the acceptance criteria before the product go to life. And so if developer builds something that cannot be managed by ops, the product will fail and the business demands will not be met. So typically the enterprises conduct SLA or KPIs to fulfill their processes so that these are enabled into the business goals. If one of the processes fails, the product will be impacted as an ultimate consequence, and so the business will not achieve its goals. So understanding SLA and the KPI is important for any architect. This is why it is included into the surrounding model that we will also discuss. So the service level agreements are positioned between the tactical process of DevOps and the strategic level at the enterprise level where the goals are set. So the SLA and the KPIs should support those goals and guide the DevOps process. So you can see here in front of you 6 of the most important matrices that should be included into the SLA for DevOps. And those should be frequency in development, and this refers to that the DevOps teams usually work in sprints. This is a short period of time in which the team works on a number of backlog items as part of the next release of a product. The KPI measures how often new features are launched on a regular basis. And here keep in mind that the new features can be scheduled on a monthly, weekly, or daily basis. Then the development time is usually the time between the code being released after the test phase. Then the deployment failure rate on the other side refers to the rate of failures that occur after deployment. Ideally, this number should be 0, but this is not realistic. Deployments, especially when the change rate is high, will fail every now and then. Obviously here, we should aim that this number is as low as possible. Then we have the matrix that is called deployment failure detection time, and this is due to the fact that KPI strongly relies on the previous one. So failures will occur, but then the question is how fast are those failures detected and when we will be able to fix them. So this type of KPI is also referred as mean time for recovery, and usually this is the most important KPI on the DevOps cycles. And then we have the change lead time, which is the time that is between the last release and the next change to occur. Subsequently, it is measured in terms of how long the team will need to address a change. Shorter lead times indicate that the team works quite efficiently. And finally, we have the full scale time. I know that there are a lot of times here, but as you can see, the definition of time during DevOps is quite important. So the full scale time is the total time that is between the different iterations for each development. So this is the main list that I wanted to share with you. This list is of course not executive, and so the enterprises can think of a lot of different metrics and KPIs that they want to implement. But I would always advise you to keep the things simple. Keep in mind that every matrix that is included in any contract needs to be monitored and reported, and this could become quite expensive and time consuming. So let's talk a little bit about the team value on the project, and this is usually implemented with the voice model. So the DevOps teams need to deliver value to the end customer. This is their main goal. So the voice model is specifically defined to address this. As you can see from the graph, the voice model includes value, objectives, indicators, confidence, and experience. Voice. The idea behind the model is that any IT delivery should deliver value to someone, typically the end customer of the business. Value sets the objectives of the IT delivery, and those objectives are measured using indicators. So indicators measure whether the pursued value is achieved. Then confidence is all about the indicators and if they contain relevant information to confirm that the IT delivery actually results in the targeted value. And lastly, the experience basically tells us if the delivered system is fulfilling the business demands and which improvements will lead to more business value. And then the circle starts again from value. So since the voice model also involves looping feedback back to the beginning of the cycle with the aim of improving products and adding more value to business, the model can be used for any DevOps project. So thank you for watching this video and this section, guys. I hope you learned a lot about the DevOps, and in the next video we will continue our introductory sections with the DevSecOps, so we're going to add the security level there. Hi everyone, and welcome to this section in which we're going to introduce ourselves to DevSecOps ecosystem. So as everything into the IT world, the DevSecOps requires architectural foundation. So in this section, we will learn how to compose a reference architecture for the DevSecOps, and there's some practices to design the pipelines with the DevSecOps. We will also discuss the best DevSecOps practices for the major public cloud providers such as AWS, Azure, and Google Cloud. So in the previous section, we were discussing the principles of the DevOps, and so we concluded that security should be at the heart of every setup in the development lifecycle, from the moment where the code is pulled from the repository to the actual code being committed and push to the production. So the DevSecOps consists of three main layers. The first one is the culture, and this is not a technical layer, but it is quite often forgotten that DevOps is much more than applying tools and creating CI/CD pipelines. Obviously, the same applies for the DevSecOps. Within the DevSecOps, every team member feels responsible for security and acts accordingly, taking ownership of it. This doesn't mean that the security specialists have become obsolete though. It's good practice to have security engineer or professional in your team, sometimes referred as a security champion. This person should lead out the processes in the team for applying security standards and policies to ensure compliance. The next layer is the security by design. So the security is embedded at every layer of the system. This typically means that the enterprise has a detailed architecture that covers every aspect of security and enforcing security postures into systems, such as authentication, authorization, confidentiality, data integrity, and more. Software developers do not need to think of security every time they design and build new applications or features. And the final layer is the automation, because in DevOps we want to automate as much as possible. And the same accounts for the DevSecOps, because this also includes security. So by automating the security, we can easily prevent human error, and we can create automation tools to scan for possible vulnerabilities or non-compliant components such as unlicensed code. Automation also implies automated audits and collection of evidence in case of attack. So the automation process makes sure that security metrics are collected and sent back for feedback in the DevSecOps practice. For example, when you scan vulnerability in the code, an evidence from that scan will be collected and will be sent for feedback. So to manage those three layers, the DevSecOps relies on four main components, and those are harnessing responsibilities, application security, cloud platform security, and vulnerability assessments and testing. And so the DevSecOps should not be mixed with the security as a service. The security as a service can be compliant with the DevSecOps practice, but the concept of the security as a service is mainly about shifting security as responsibility to a service provider. This is a sourcing model that allows enterprises to get cybersecurity delivered from a service provider on subscription base. There are good reasons for implementing the security as a service, and one of them is that a provider is responsible for all security updates based on the latest insights. Enterprises can define security level agreements for incident response times and the timely application of security practices. So, before we discuss the reference architecture of the DevSecOps, we need to understand what the role of the DevOps is and how the security fits to it. So, DevOps is about the software development lifecycle. An important note is that we have to make sure that we know the fact that the developers increasingly use open source tools. This makes sense since provides great flexibility when developing new code. Open source is community driven, so developers can contribute to each other's code and speed up the process. Projects can be shared at open source platforms such as Git and GitHub repositories, but they can also be shared internally within the enterprises. So the inner source type projects are a good example of projects that are held internally. So inner source uses open source best practices for software development within the boundaries of the organization. In fact, we need security from the start of the DevOps process. In practice, this means that we start scanning for security issues from the moment the code is put from the repositories. The repositories are part of the software development lifecycle as well, so they should be protected from unauthorized access. And so this calls for role-based access and identity and access management are quite important for the repositories. They're called RBAC and IAM. So you should keep in mind that we can create reference architecture for DevSecOps within those four components. The first one is a repository access within the row-based access control, the static application security testing, which will detect errors in the source code, the software composition analysis, which will detect dependencies in the source code, and finally the dynamic security testing, which will dynamically scan the code every single time. Those components are embedded into the DevSecOps pipeline and are quite important. Hi everyone, and welcome back to the course. In this video, we will talk about the concept for building DevSecOps pipeline. So right here in front of you, you can see two pictures, and here on the top, you can see the DevOps pipeline first, and then in the bottom, you can see the DevSecOps pipeline. So let's first talk about this graph here on the top. So you can see that here we're having 4 steps, which are pull code from the repository, then build that code, then test it, and finally, once the code is tested, then we need to deploy it. So you might think, what else do we actually need to add to this pipeline? It looks perfect. Well, the main thing that this pipeline is missing is security. So this is the main thing that we're adding to the DevSecOps pipeline. Using DevSecOps, we're actually integrating the security standards and principles as part of the pipeline. So security is a layer that's applied to every step in the pipeline, but it does actually include several steps. And you can see them right here on the figure below. So you can see that pretty much most of the steps are the same, and we have the pull code from the repository, build it, test it, but here we're adding this security scan test before the deployment. And you can actually see that the security scan is composing of 5 more items. So let's talk first about the dependency check. So the first vulnerability that exposes the code to a risk is the fact that the code actually relies on different pieces of code in order to run, and there are differences in the code dependencies. So developers can have controlled and uncontrolled dependencies. As a common practice, we don't want dependencies in our code. The risk is that if the code that the dependency relies on is breached, the entire application might fail. Alternatively, malware that's injected in certain piece of code but has a dependency with other code will infect the entire code stack. For that reason, the main rule here is to eliminate the dependencies, which is one of the basic principles for Zero Trust. So you might know the most common tools to manage your packages, such as the pipe in Python and the npm in the Node.js. So commands such as pipe env check and npm audit will actually show you the dependencies. And we're going to try and test each of those commands into the next sections, which are more practical ones. Then there are the static analysis, and those are checking the bad coding practices, such as the bad configurations. There are quite a few open source tools for almost every coding language. Then, in the scanning section, developers will likely use continuous usage of containers and container images to build and package their applications. These images need to be scanned for vulnerabilities in the libraries that they are used. The scanning is done with some basic lists of known vulnerabilities. You are basically checking some known vulnerabilities and execute commands in order to see if they exist in your code. The scanning can be built by industries such as the NIST cybersecurity framework or from other software providers. And finally, there the dynamic analysis are basically automated web applications that are continuously scanning to check bad handlers or missing tokens on your application. So those tokens prevent typing unauthorized commands that might come from untrusted user, or it can simply be a function on a different website. So following the diagram, now we're having a security embedded CI/CD pipeline that will automatically cover the most common vulnerabilities recognized in the code. There is one specific item that we didn't touch in this section, and this is the use of containers and how they can secure our applications. So let's talk about them next. So most developers will use containers to wrap and deploy their code. Typically, those are the Docker containers. Docker is a very famous application that is used particularly for this reason. There are some best practices when it comes to using security containers. To keep containers consistent and secured, they should be scanned regularly, even when the application has reached a steady state and updates are done less frequently or the active development has stopped. If the application still runs with its underlying containers hosting the different application components, those containers must be scanned, since there is always a possibility that the dependency is creating a new vulnerability. Applications consisting of containers are normally defined by the Docker files. You can use linting, which is analyzing the codes for errors or bad syntax, and that can be used in the Docker files to make sure that those files remain secure. A popular linting tool to use for that purpose is the headulint tool. So this tool is available as a Docker image and can easily be executed with the command that you can see in front of you. So what you simply need to do is to write docker run rm-i headulint/headulint, and we'll explore these options once we start installing and organizing our Docker images into the next sections. Docker also recommends some best practices for keeping containers secure. So Docker already takes care for the namespaces and the network stacks to provide isolation so that the containers can't obtain privileged access to other containers, unless this is specifically specified in the configuration. So some specific things to consider is that Docker always uses Docker domain. This domain requires root access, which implies security risks. The first thing is that only trusted users should be allowed to set controls on the domain. You also need to take action to limit the attack surface of the domain by setting access rights to the Docker host and the guest containers, especially when working with containers provided through API web server. So if we follow up the recommendations for Docker, we will have trusted, immutable images that we can use to deploy containers on Kubernetes, for instance. And Kubernetes, for which we'll really talk in detail in our next sections, will actually use the trusted image repository and take care of the provisioning, scaling, and load balancing for the different containers. The security features of Kubernetes is a support for rolling updates. If an image repository is updated with patches and enhancements, Kubernetes will deploy new versions and destroy the previous ones. So in that way, developers will always be sure that only the latest versions of images are used. So database credentials, API keys, certifications, and access tokens must be stored in a safe place at all times. The use of CI/CD and containers doesn't change that. It is strongly recommended to use a vault outside repositories that the pipelines assess for CI/CD. So the best practices for secret management you can see right here in front of you. They're account to 3, and the first one is encryption with AES 256 encryption keys. The second best practices is that secrets such as keys must never be stored on Git or GitHub repositories. They should be stored in some local space. It's also advised that secrets are injected into application using secure string as an environment variable. So for example, if you have a project, it is not recommended to just type this key as a string into your code, but instead you can create an environmental variable, assign to that variable the key, and then simply pass it to your code. So for example, HashiCorp offers Vault as an open source solution for security assessing secrets. The service allows to easily rotate, manage, and retrieve database credentials, API keys, and other secrets throughout the lifecycle. Even more robust solution can be provided by a service called CyberArk, which is a platform independent on secrets management solution specifically created for securing containers and microservices. So these tools or these security tools could be integrated to Azure and AWS, and so you can use, for example, Azure Key Vault or AWS Secret Management. So this is actually something that we will talk in the next video, and there I will explain you how you can secure your AWS, Azure, and Google Cloud platform using DevSecOps. You can find the complete course on the link in the description. Hi everyone, and welcome back to the course. As I promised, in this video we will talk about how to use DevSecOps with AWS, Azure, and Google Cloud. So let's get started. So in the previous videos we discussed the DevSecOps principles and how the pipeline is built with embedded security. So in this video we'll look at the best practices for applying DevSecOps in the major public cloud platforms such as AWS, Azure, and Google Cloud. So let's first talk about how we can implement DevSecOps on AWS code pipeline. So before starting to explain the DevSecOps in AWS, we need to understand that deployments in AWS should be based on the principles of the Cloud Adoption Framework. The framework covers specific security tasks and responsibilities grouped into 4 categories, and those are prevention, detection, correlation, and direction. So as you can see on the figure in front of you, AWS offers native solutions to provide controls for managing security postures for CI/CD pipelines. So here on the pipeline, you can see the different steps organized. So an important artifact here are the security groups. As you can see, those could be bins where the security posture of all of the components that are developed and deployed in the pipeline are defined. It contains templates and policies that have to be applied to those components. So you can see that the code is going from the Git repository to S3 bucket, which basically is something like a drive in which we can place any type of data, mainly used for images. Then we put the code to the code pipeline, and then it goes to the different security groups. So the static code analysis are performed on the code that is pulled from the S3 bucket right here. So once we pull the code from the S3 bucket, we're creating a stack of containers that contains virtual private cloud in AWS to run tests. So those tests are used to run the code on the stack and validate the build. AWS calls this stack validation, and then certain Lambda functions validate the stack against each and every security group. Okay, so everything that has to be defined into the security, we need to meet in those security groups. So this is the second station, which is a test. And so after that, we're running into the production. So in the production, after the successful stack is validated, a Lambda function is triggered to prepare the stack for production using the CloudFormation templates. So examples of items that are checked against security groups can be validated using access and permissions, access controls to the S3 bucket, and policies to create instances using, for example, EC2 compute resources. So Microsoft Azure actually uses a different approach from AWS when implementing DevSecOps. This solution leverages the scan possibilities of GitHub. It also leverages the features of the Azure Kubernetes services next to the Azure pipelines. And you can see it right here. So here in this diagram, you can see high-level architecture for a security embedded CI/CD pipeline using GitHub and Azure services. You can also see certain numbers in the diagram, like right here is 1, then 2, 3, and 4. Okay, so those numbers represent the order in which each step is taken when working on the cloud. As soon as the containers are pushed to the Azure cloud repository, they are scanned against the policies that are stored in the Azure policies, right here that you can see. So first we push the containers, and after that, in the next step, we're validating against the Azure policy. So after that, the appropriate security keys right here are fetched to authenticate the containers to the Azure Kubernetes service. Only when all checks have passed successfully, the code will be then pushed to the application gateway. So if we look a little bit more in detail, we can see that the Azure cloud is quite secure, and the solution starts with the code analysis in GitHub, which involves using CodeQL to detect vulnerabilities in the source code and dependencies respectively. Then once the code has been validated, it's packed to Docker container and deployed to a test environment using the Azure DevSpaces. This is done through the Azure pipelines. So the Azure DevSpaces will build an isolated test environment for the Azure Kubernetes service. Then when we scan our code, containers are stored into the Azure Container Registry, where they are scanned against the security protocols. To do this, Azure uses the Azure Security Center, which is a huge library that holds all security policies for the environments enrolled in Azure. And finally, when we reach our production stage, the scanned containers are pushed to Kubernetes cluster using the Azure Kubernetes service. Azure policies are used to validate the compliance of the provisioned clusters and containers. So just like the AWS, Azure uses several different solutions to provide end-to-end solution that embeds security roles, policies, and postures throughout the whole CI/CD process. However, all those solutions start with repository where those security guidelines and guidances are stored and managed. Security groups that are managed through AWS Security Hub are located into the Azure Security Center. So let's see how the DevSecOps are actually implemented on Google Cloud. Well, this is normally done using the Anthos and the JFrog methodologies. So the Google Cloud involves interesting best practice solutions for implementing the DevSecOps pipelines using JFrog. So it doesn't only provide cloud native pipeline, but also a solution for developing and deploying hybrid environments using the Google Cloud and the on-permission systems. This is quite interesting for enterprises, since a lot of enterprises will not move their IT systems completely to public clouds. Most enterprises are expected to move more and more systems to the cloud, but some of their system will remain private in the stack. So CI/CD pipelines that are suitable for both cloud and on-permission solutions are quite favorable, and with Kubernetes they're quite easy to set up. So you can see the architecture here in front of you using JFrog right here and Kubernetes. So there are two major solutions, and the Google Cloud advocates for using JFrog Artifactory and JFrog X-Ray. So JFrog Artifactory takes care of storing artifacts that are used when building applications. So we already saw how pipeline starts by pulling code from the source repositories. Developers need to be able to rely on the tooling that stores and other artifacts, code building blocks, in a comprehensive and safe way, so that software delivery to the pipelines can be automated. and I've been actually using and still use Artifactory for my current projects in the company I work for. The JFrog X-Ray scans the artifacts and the code building blocks through Artifactory against known vulnerabilities and license compliance. X-Ray uses the shift left mentality by already scanning the source artifacts. And you can see the complete diagram right here in front of you. So JFrog is basically using X-Ray as the main security solution that is embedded to the pipeline. Builds are taken and then pushed to the production using the Kubernetes Google Cloud Platform and on a platform called Antus. So Antus ensures a consistent layer of deploying and managing Kubernetes clusters across the native cloud of the Google Kubernetes engine and on permissions. This solution is only feasible with Google Cloud, but can be also used on the VMware stacks as well as on the AWS as well. So this is how DevSecOps can be implemented on all of the major cloud service providers. Hi everyone and welcome back to the course. In this video we will plan our deployment of the DevSecOps and also we'll talk about the industry security frameworks. So let's get started. Now, so far we discussed the reference architecture of the DevSecOps pipelines and the best practices for AWS, Azure, and Google Cloud. If we have the architecture, the next step would be planning and deploying DevSecOps and the pipelines to our enterprise. There are three major steps that most of the companies will need to implement the DevSecOps. The first one is to assess the enterprise security. So enterprises will likely already have adopted security policies and taken measures to protect their systems. They will also need to adhere security standards and frameworks because of the governmental and industry regulations. So security specialists will have to consider the risk assessments and have to analyze the possible threats. Those specialists should understand and manage the security controls. There is by default a starting point which involves these practices of managing security into the DevOps practice. So DevSecOps should never start without including security policies and standards for developing and deploying new code or a pilot project. So the next step would be to embed security to DevOps. Security policies and standards are integrated into the development process. The DevOps workflows are matched against the security guidelines. This includes vulnerability testing and code scanning. So without processes and tools in place, DevOps can't start developing new code. The risk of increasing the attack surface and causing permanent damage to the enterprise is too big in that case. So companies, both big and small, are under consistent threat of hackers and security threats. And this brings us to the final step. So the DevOps and the DevSecOps are not only about technology, it's a way of working and even thinking. It is basically a culture and people need to be trained in adopting that culture. So staff, developers, and operators need to be trained consistently to do their tasks. Developers, operators, and security engineers need to fully be committed to applying the security controls in their work, and that implies that they should always be aware of the risk for the enterprise or that the enterprise is facing in terms of security. And of course, proper tooling is quite essential in order to achieve that, at least at a minimum. And so tools for testing are quite recommended, and testing is actually one of the critical elements of the DevSecOps. The market provides a massive number of tools for performing tests. The next type of tools that we need to have are the alerting tools. So when security threats are detected, alerts need to be raised and sent out. Then we need to have tools for automated remediation And those are tools such as StackStorm to help providing remediation as soon as the security issues are detected. And finally, it's always good to have visualization tools because developers and operators need to be able to see what's going on in the systems. So you can use plenty of tools in order to achieve all those goals, and they would be mainly third-party tools that can be integrated into the DevOps tooling for either AWS, Azure, or Google Cloud. Of course, public cloud platforms themselves offer extensive security tooling. So the benefits of the DevSecOps should be clear now, but we should know that with the DevSecOps we can achieve better collaboration between developers, operators, and security engineers. And with that, we will ensure that security threats and vulnerabilities are detected at an early stage of development so the risks to the enterprise are minimized. So, because the IT becomes more and more complex over the years, the IT security is of a key importance. The level of security that is required will, of course, differ for every industry, but first of all, financial institutions will want to make sure that bank accounts can be compromised and that money are not being illegally transferred. Or on the other side, healthcare institutions will need to protect their patients' personal and health data. And in order to do that, you need to have some common rules that everybody follows, and an organization is certified if it complies with those rules. So, before to learn how the security frameworks impact the CI/CD and the DevOps, we need to understand those frameworks. So, basically, a framework is a set of policies and documentation guidelines on implementing and managing those best practices for different types of organizations. And actually, I have very good courses on NIST, Cybersecurity and Risk Management Framework, that you can definitely take a look because they cover all the security practices that can be applied to DevOps and DevSecOps. So, some of the most famous practices that you should be aware about are firstly the ISEC 27001, which is an international standard for system security controls that emphasizes on controls that detect threats that will have severe impact on the availability and the integrity of the systems. Then you have the NIST cybersecurity framework that doesn't specify controls, but it does provide 5 functions to enhance security. And those are to identify, protect, detect, respond, and recover from a risk. Those functions will allow organizations to set controls to manage data breach risks. Controls should include access controls, measures to protect data, and also awareness among staff. Then we have the CIS framework, or the Center of Internet Security Framework, which offers extensive frameworks with specific controls for platforms, operating systems, and databases, even containers. Some of the CIS frameworks are embedded into the platforms such as Azure or AWS, and the CIS benchmarks could be assessed easily through Azure Security Center and AWS Security Hub. And finally, there is the COBIT framework, and COBIT stays for Information System Audit and Control Association. So COBIT was about identifying and mitigating technical risks in the IT systems, but it also covers the business risks and the release of those risks that are related to IT. So those control frameworks, guys, could have editions that cover specific industry requirements, but typically industries have to incorporate their own standards or be fully compliant with the existing ones. This is important when industries are audited. Hi everyone, and welcome back to the course. In this section, I'll review the main containers or container platforms that provide infrastructure for both developers and operation teams. And the main ones that we will cover are the Docker and the Kubernetes. I will also review some alternatives like Podman and other platforms. So the containers are one thing that are very important, and they're helping to streamline the process of moving applications through development, testing, production, and so on. Docker and Kubernetes are really helping to reinvent the way applications are built and deployed as collections of microservices rather than previous monotonic approaches. So, DevOps aims to improve the quality of the new software versions and accelerate the development, delivery, and implementation because of its effective cooperation with the continued automation. So, automated DevOps tasks include automated build processes, static and dynamic code analysis, and performance testing. The core spine of the DevOps is still reflecting the continuous integration and continuous delivery of the automatic deployment of applications. So, of course, Docker must offer options for consolidating CI/CD tools like Jenkins and allows you to automatically load your images from the Docker Hub repository or version control repositories like GitHub or Bitbucket. This is how the container platforms represent the base of the DevOps workflows. And in those, developers can create new components for application in common and run them into any testing environment. So let's talk a little more about Docker. So Docker is a container platform to quickly develop, deploy, and manage applications, and its main task is to package software into serialized units called containers that include everything necessary for the software to run, including libraries, tools, or code. So with Docker, you can deploy and quickly adjust the scale of applications in any environment and be sure that your code will run the same. You can do that in production environment or in cloud or local location. You can always access the hub.docker.com, which is a repository where Docker users can share images that they have created with others. So for Linux or Mac or even Windows, it is quite easy to download and install those containers or applications into the Docker package manager. So let's try to make a difference between containers and virtual machines. Now, you can see in front of you a diagram that is defined by Docker in which applications run inside completely independent containers. So we will compare the Docker application containers with other type of environments such as the virtual machines. So as you can see, containers have multi-level abstraction above the hardware abstraction. Virtual machines allow the abstraction of physical hardware, while the hypervisor allows multiple virtual machines to run at the single computer. Each virtual machine includes a full copy of the operating system, applications, and the required libraries. However, with the use of containers, resources can be isolated and services can be restricted. In that case, processes are given the ability to have an almost completely private vision of the operating system with its own process space identified. So, as you can see, multiple containers share the same core, but each container can be restricted to using defined amount of resources such as the CPU, memory, or input-output resources. So because of this container structure, Docker takes better advantage of the hardware and only needs a minimum system files for its services to work. It doesn't need multiple versions of the same operating system installed in virtual machines. So the containers in Docker are self-managed, so they don't need anything more than an image of the container for the services to work. A Docker image can be understood as an operating system with dependencies for supporting installed applications, and so the container is created from a particular image and it always works. Docker's images are also portable between different platforms, with the only requirement being that Docker is installed and the service is running on the host system. You can also use repository of images such as GitHub or Bitbucket code repositories, and this service is called Docker hub registry. So let's talk about the Docker architecture. So you can see on the graph in front of you the complete Docker architecture. So because of its architecture, Docker offers a great portability because all the containers are portable, so we can take them to any other Docker device without having to reconfigure anything. And so Docker allows you to run your applications locally on any operating system and on any cloud server such as Google Cloud or AWS. You're getting great performance because all the containers are based on Linux containers which runs directly on the kernel of the host machine, avoiding traditional visualization layer that is common for other platforms. And the best thing is that Docker is responsible for everything. So all the containers will have everything necessary for the application to work, and you will see that in our next videos actually, where I will show you how to install Docker and run Docker containers. So as you can see on the figure, Docker uses client-server architecture where the client port communicates with the server port right here, and the daemon, so that is in charge of building, executing and distributing containers. Client and server are able to run both on the same host and on different platforms as well, since the communication between them is performed using the RESTful API services. So let's talk about the different components in this diagram. Now, firstly, the Docker engine or the daemon, which is basically the main core of Docker, is a process that runs on every Linux distribution and exposes itself to external API for management of the images and containers. This process is responsible for creating images, uploading and downloading Docker registry, and executing and managing containers. Then we have the Docker client right here, which allows you to manage the Docker engine and can be configured to work with a local or remote Docker engine. It allows us to manage both local development environment and production environment. So this is connected to the Docker image, which is simply the template that is used to create container for the application that we want to deploy. And then we have finally the container right here, and those have the folders with everything necessary so that the application can be executed. The Docker tool offers the ability to package and run an application in an isolated environment that is actually called container. So to use the Docker, you can use the command line interface, communicate between the servers and the client, and to do that, the REST API is used. The Docker daemon process is responsible for creating and managing objects like images, containers, networks, and volumes. So actually the components that make the basic architecture of the Docker engine are actually the API, the command line interface or the client, and the REST service. The name daemon process means that the server works in the background of the host system and allows central control of the Docker engine. The REST API specifies a series of interfaces that allows other applications to interact with the Docker daemon. And finally, the command line interface uses the terminal, and this is the commands that you're writing from your terminal because you're the client, and interacts with the daemon using the REST API. It is pretty simple. Hi everyone, and welcome back to this course. In this video, we have a hands-on tutorial on how you can install Docker and run containers. So let's get started. So here I am in Google, and you can simply write Docker download, and this will help you to find the first page from which you can download Docker for your distribution. So let's hit on it, and depending on your operating system, you can download Docker from here. Since I'm using Mac OS, I will download Docker for Mac, and depending on whether you use Intel chip or Apple M1 chip, you can choose either download. I'm using an Apple chip, so I'll hit Mac with Apple chip, okay, and you can see that the Docker image starts downloading inside my device. So once downloaded, just click on it and you will see this window right here. So just take it and drag it to your applications. And after a very small amount of time in which your application will actually start installing, you have Docker is installed in your device, and you will be able to run all the commands related to Docker. Okay, so the installation is completed now. I will close the window and I will search for Docker. Okay, so now the application will run into your device and you will see a graphical interface. Click OK here. And then you can see the Docker application in your device that is starting right now. So as you can see, because I've never actually run anything into Docker so far, we have no containers whatsoever. So let's open the terminal and actually run some basic containers here. So write terminal, okay, and I will actually increase the size of the terminal so you can see it better. And so here, let's first write Docker, okay, just to make sure that you have it installed. So if you see those commands, this means that the Docker has successfully been installed in your device. Then do Docker -- version to see the version of Docker and make sure it is the last one. Now, since we have that, let's create a container, a basic one. Let's run the hello world container. So you can do Docker run hello world. Okay, so you can see that this run properly and actually something happened on the back. And here it is. We have our new container that is called hello world. Okay, let's create another container and you can do Docker run -d -p 8080 Docker / getting started. Okay, so let's run that command and this will create another container called getting started. You can see here, and this container will actually run. Okay, so you can see that this one is active and the other one is exited. And you can play with the containers from the graphical interface, so you can stop it from here or you can start it. And you can either use the graphical interface here or you can simply copy the name. So I'll copy this name and go to your terminal and write Docker start, and then you can write the name of the container, and you can see that once I run this, the container actually is running now. And if you do, for example, stop instead of start, so let's do Docker stop, okay, you can see that our container has stopped, and you can also see the port. So for example, the other container will not be able to run it because we didn't define port while creating it, so that's normal. But of course, if you have multiple containers, you wouldn't want to activate them just from the graphical user interface, but I would prefer, of course, to activate it from the terminal. So as we said, the Docker client uses remote API of the Docker engine and can be configured to talk with the remote Docker engine. This allows us to manage both local development environments and production servers. So in order to check all the commands available for Docker, you could simply write Docker and then you'll see all of them. But the most common ones, I would say, are, for example, the Docker images, which will show you all the images that have been used or you have available on your device. You can also do Docker info, and this will give you info for the current Docker client server, such as CPU cores, memory, and so on and so on. You can pull images, for example, from a Git repository by Docker pull, or you can push them by Docker push. You can delete image, for example, with Docker RMI, or you can run images with Docker run. You can also check, for example, the processes with Docker PS, and so on and so on. There are actually a lot of commands, so I'm really advising you to explore all the commands of Docker. And of course, throughout this course, we're going to cover plenty of those commands because Docker is a key part of the DevSecOps. So let's now, just for fun, try the pull command, which will help you to download a container from external repository that is not in your device. So let's do Docker pull. Okay, and let's do ng inx, and this will hopefully download the ng inx container and install it. So let's do that. Okay, so you can see that this has downloaded the image, right? And so now once the image is downloaded, let's actually check. So let's do Docker images, okay, and you can see we have the ng inx. So once we have it, we can actually run it. So let's do Docker run -i -t nginx bin bash. Okay, so let's run that, and you can see that another container appeared, and this is the nginx container which we downloaded and then run into our device. So now this is running for about 12 seconds, and so let's stop it so it doesn't run on the background. So let's actually run back this container again. So I will do docker run -i-t nginx, and actually here when we're writing bash bin, this is because so we can access the console of the nginx container. So let's run that, and you can actually see that here this changes, and the reason is that when you write bin bash, imagine the container as another device. So if you would like to write commands in this container, then you can write bin bash and you access the console of the particular container that you're running. So for example, if I do here ls-l, okay, you will actually see all the content of this container with all the file system. And so if you would like to exit, for example, you can simply do exit and you exit the container console. And you can see even here that this is exited. So let's close both of those runs. And hi everyone, and welcome back to the course. In this video, we'll talk about Podman and how to manage your containers with Docker. So before moving to the practical exercises, let's first talk about Podman. Podman is a native open source tool that doesn't use daemons or background processes. It's designed to facilitate the search, execution, construction, sharing, and deployment of applications using open continuous initiative. The key feature of Podman is that it doesn't need daemon process for controlling the instances of each container. This provides opportunity to access various visualization applications without root privileges. So Podman is a container engine that allows us to lift containers in a similar way to Docker, but with some key differences that you can see here in front of you. The first one is, as I mentioned, it is rootless. So it doesn't need root privileges in order for us to execute containers. So thanks to the Podman modular architecture, it is not necessary to execute our containers as a root, which is quite a big advantage, as we can execute our containers with different users who have different privileges. This happens without the risk for someone who has access to container to execute the container as root user. The second main advantage is that it is daemonless. It doesn't need to raise a single daemon for many services to work. So Podman is quite similar to microservices architecture and executes the necessary services for each container. Then you have the pods. So Podman has pods, which is actually a term that also comes from Kubernetes. So we could lift pods from one or more containers and isolate them from their pods. As you know, pods are small deployable units of computing that you can create and manage. Pods are usually a group of one or more containers with shared storage and network resources. And finally, Podman has a command line tool, quite similar to the one of Docker as well. So there are not much differences there. So if you started on Docker and you wanna move to Podman, then you don't need to actually learn as many new things. So in addition to the fact that you don't use domains, as we mentioned, one of the key features of Podman are the pods. So pods allow us to fuse multiple containers in a common Linux namespace that shares specific resources. You can also apply a wide variety of visualization in the same way. So in that way you can run multiple containers as a user without root privileges. So the main idea when using Podman is to have a main container that has inside one or more side containers running in the same pod of the main container. In this way, containers within the same pod cooperate with each other to execute a particular service. So here I bring you some of the most interesting characteristics that Podman actually has. The first one is that it has a syntax that is quite similar to Docker, so you don't need to learn new set of instructions to manage your images into the containers. And yes, Podman actually manages the entire container ecosystem, including the pods, containers, images, volumes, And this is done by using the libpod library. And so if you see this GitHub web page, you can see that you can mount Podman compose and you can use it as a Docker compose from here. But let's leave that page for now and let's check out what are the Podman commands. So I will open here a terminal and I will get a little bit closer so you can see. And first of all, if you want to check out all Podman commands, you can simply go to docs.podman.io, and here you can see the different commands related to Podman. As I said, they're quite similar to Docker, so it shouldn't be that much of a learning curve there. So guys, in order to install Podman into your device, you can go to podman.io, getting started installation, and you can simply write brew install Podman for macOS. For Windows, you can click on the separate guide, or if you have Linux, you can check your Linux distribution from here and then write the appropriate command. Since I'm using macOS, I would just need to do brew install Podman. Brew is actually another service that if you don't have it, make sure that you install it. So go to brew.sh, copy this command right here, okay, and you can install brew, which is the installation tool. So I already have it installed, but I will just paste that here and run it. It is a root privileges command, so write your password, okay, and then brew will start installing inside your device if you don't have it installed yet. So once this is installed, then you can install Podman by simply copying brew install Podman, okay, click enter, and then since I already have it installed, I will see this message that Podman is already installed and up to date. But for you, since you don't have it installed, it will take you about 5 to 10 minutes until the installation is completed. So if you want to check all the commands that are available for Podman, you can simply do podman --help, okay, and you get all the commands that, as I said, are quite similar to the ones of Docker. So in order to use Podman, firstly you need to do podman machine init, and once you write this command, then a CentOS image will start downloading into your device. And this is because Podman uses a Linux system to operate. So you can start now the machine by writing podman machine start. So let's do that. Okay. And now your virtual machine for Podman will actually start. So now your machine has started successfully, as you can see in the background. And if I write PS, you can see that there are also some processes in the background as well. So let's get our Docker container with this command podman pull docker io library httpd, okay, and you can see that now we're pulling our docker io into Podman. So this is completed. So then let's do podman images, and here you can see the list of all the images that you currently have, and obviously we have only the docker io image that we just downloaded. So now let's run it in the same way that we were running containers in Docker. So here we use the same command actually, which is the run command. So let's do podman run -dt-p, then specify the ports, the protocol, and finally the image. Let's run that. Okay, and now here you can see the process which you have running into your background. But how you can find your process? So if you do podman ps, okay, you can see that you have one process in the background that is currently running, and this is your Docker image, as you can see. So now if you do curl http localhost and the same port that we stated for our Docker container, you can see that we're getting something, which means that this works. Okay, so this is the output message here. And so let's inspect the container that we just created by firstly writing podman ps, and you can see here the name of the container, or the ID actually, and you can simply write podman inspect and then just copy and paste the ID. Okay, so you can see now the configuration of all containers in our device. So here is the ID, and we only have this Docker container that we downloaded. And so if you need anything related to its configuration, you can definitely check it from here. Now, another cool feature of Podman is that you can actually search for images. So let's do podman search python Okay, and you can see here all the images related to Python that you can actually download in your device, and you can download them by using the pull command in the same way as we did with the Docker image. So now let's actually close our container and exit Podman, and you can do this quite easily by doing Podman stop, and then let's place the ID of the container, and this command will actually stop our container. Okay, and you can also do Podman rm and then the ID of the container, and you can see that now, since we get this ID back, our container is removed. So if I write podman ps, you will see that there are no processes running, or if I do curl, you will see that there's absolutely nothing. So we failed to connect to the port because the port 8080 is no longer connected to our container. So I know that Podman might not be as intuitive as Docker, since Podman doesn't have a graphical user interface, but trust me, it is quite a powerful tool that you can definitely use. So you should know that using those tools, managing containers, have completely changed the way people think about software development, deployment, and maintenance. Containers are so light and flexible that they've given rise for new architectures and applications. This new approach consists of packaging the different services that are part of application into separate containers and then deploying those containers within a cluster of physical or virtual machines. When developing a simple code, the administration of that code doesn't require large resources. So the need for container orchestration starts appearing into the project. So container orchestration is a tool that automates the implementation, administration, scaling, the creation of networks, and the availability of application based on this technology. So nowadays, applications are quite complex and tend to appear towards microservices, meaning that we should have at least one container for the front end and one or more service interfaces and another for database. So all of these things give the need for the container orchestration, that is having a tool or system that automates the development, management, scaling, interconnecting, and availability of container-based applications. The container orchestration is basically responsible for the development and deployment for automatic container-based services, for the self-scaling and the load balancing of the system, and to control the health of each container. So to do that in Docker, you can actually use the Docker Compose. So Docker Compose, as you can see here, we're on the front page of Docker Compose, and it basically allows you to connect several containers and execute them with a single command. It is implemented in Python, and it uses a file called YAML based on the YAML makeup language. So the Docker Compose allows you to define a series of containers and the relationship between them at a level of a YAML file that is very intuitive in its format. So as you can see, this can be done in a few steps by creating a dictionary of the project, for example with Flask, creating a Docker file, and compose file, which is actually our YAML file. This file includes all the dependencies and their interrelations. This allows the management of multi-container applications, and to manage that, the techniques that you need to use don't actually differ from the standard techniques that we use with a single container. With the Docker Compose command, the corresponding subcoming commands actually manage the entire life cycle of the application. And right now, we will not actually go into too much detail on how to do that. I just wanted to show you the front page so you're aware of this, but we will definitely explore this more and apply it to our application. So we will definitely have projects where we will create a Docker file, YAML file, and so on. The YAML file basically has all the libraries, volumes, ports, and other important information for each of the containers that we have. So that's it. Thank you very much for watching this video, guys. And in the next video, we'll talk about Kubernetes, so I can get you started there and Then in the next sections we will explore how Docker and Kubernetes are basically one of the key components for building the DevSecOps. Hi everyone and welcome back to the course. In this video we will talk about Kubernetes. So the advantage of using containers to run a group of software applications is already established using Docker. However, in a production environment, managing and running containers is important to minimize the downtime of the service. And this is where we're using Kubernetes. Kubernetes is used to automatically start a new container if a container fails. So Kubernetes follows master-slave architecture and it is also known as K8s. This is the most popular container orchestration engine on the market. It is open source for applications executing in software containers, automating the deployment, scalability, and management of the distributed applications. So Kubernetes groups the containers into logical groups called pods, which represent the basic unit of the manager that can be distributed in the cluster by the Kubernetes process. One pod can have a set of containers that share the same storage and a single IP address. So the Kubernetes, as I mentioned, has a master-slave architecture, and so the master container, as you can see on the figure right here, control and schedules all the activities of the container, while the workers right here, as you can see, are actually the nodes. And here is where the containers are executed. You can have multiple nodes for one Kubernetes master. So the ability to have multiple nodes or orchestrated containers makes Kubernetes a perfect addition to the microservices-based applications. So the master container right here acts as a central control level in the cluster, and it's composed of 4 basic elements that allow coordination within the cluster and to distribute tasks. So those are the IP server, which is responsible for launching all automations in API server by using RESTful API services. The server acts as a central management point in the cluster. Then we have the etcd, which is an open source key value store and can be considered a Kubernetes cluster memory. It's been developed especially for distributed systems to store configuration data. Then you have the scheduler, which distributes the pods in the cluster, so it finds out how many resources a pod needs and basically adjusts them within the resources available for each node in the cluster. And finally we have the controller manager right here, which is a service of the Kubernetes master that manages the status of the cluster and executes the routine tasks directing the orchestration. So the main function is to ensure that the cluster state corresponds to the state that was previously defined as an objective. So while the master is responsible for the orchestration, the distributed pods in the cluster are running different nodes called workers. To do this, each node needs to run a container engine compatible with the container tool like Docker or Podman. So you can imagine that basically Kubernetes runs the master and have multiple containers as Docker, or actually a container tools as Docker, which contain multiple containers. So one Kubernetes could have a few Dockers or Podmans or any other such tool. And so let's talk about what each Kubernetes node includes. So the first one is a kubelet, and this is used to direct and manage the node. This process maintains the communication and ensures that the information is sent to the worker nodes. The agent receives the requests and supervises their execution in each node. Then you have here the kube proxy, which is a proxy service that is executed in each Kubernetes node to serve the requests that come from worker nodes and provide services to the users of the container application such as Docker. And as you can see, these proxies, they go directly to the users right here, and this is how the services are provided. So in order to understand Kubernetes better, let's talk about some of the key terms using Kubernetes. So the advantages of using containers to run in a group software application are quite a lot. And Kubernetes extends that by creating the ability for us to have multiple container application tools that consist of multiple containers. And here I bring you some of the key capabilities that Kubernetes can provide. The first one is the service discovery and the load balancing. And this is quite important point. Kubernetes can expose a container using its own domain name and IP address. It is also capable for balancing the workload and distributing the traffic in a way that the deployment is quite stable. The next key point is that Kubernetes provides storage orchestration. It allows you to automatically mount a storage system of your choice, such as local storages, public cloud, and any other type of computing providers. It allows you to describe the desired state of your payload containers, and you can change the current state of your containers to desired state. For example, you can automate Kubernetes to create new containers for deployment, remove existing containers, and adopt all of its resources into a new container. Also, Kubernetes can actually restart the containers that fail and is replacing the containers that are not responding within the cluster. Then you have the resource management. As you can see, Kubernetes is actually all about management and allows you to specify how much CPU and memory or RAM each of the container needs. So Kubernetes can actually take better decisions than the developers to manage container resources when containers have specified resource requests. It can also provide secret and configuration management. It allows you to store and manage information related to the configuration of the containers, as well as the most sensitive information like password, keys, and tokens. This sensitive information and the configuration parameters can be updated without the need to reconstruct the container images and without the need to open the sensitive information. So there are also some additional terms that you need to understand in order to get better understanding of Kubernetes. So firstly, we already talked about cluster, and cluster is a physical or virtual resource and storage resources used by Kubernetes where pods are deployed, managed, and replaced. So cluster is basically a storage location. Then you have the pods that are a smaller unit that can include one or more containers. In many cases, a pod is composed of single container, but its ability to accumulate several containers very close to each other is quite powerful feature. Then you have the replication controller, which is a Kubernetes mechanism to ensure that a pod has raised a certain number of replicas. For example, the replication container raises more replicas if you need more and kills them if you need less. It raises new replicas to keep the number defined if any of them fails or dies. Then the services define how to access a group of pods and allows access to containers with a unique domain name server and IP address. And finally, the labels are used to organize and select a group of objects in pairs of key and values. So a pod can contain one or more containers running at the same time, and it is basically the unit that the Kubernetes manages. So there are several advantages that Kubernetes brings to the management of containers as pods. So before starting with the Kubernetes configuration, you should understand that there are 4 key concepts that you need to know. Those are the Kubernetes driver, which acts as a node from which pods, replica controllers, and services of the Kubernetes environment are deployed and managed. And later on, I will show you how you can create a Kubernetes driver. Then the Kubernetes nodes provide environment in which containers can be executed. Later, we'll run the command kube proxy in order to start all the containers within a node. Then we have the kubectl command, which is used to do the Kubernetes management into the master node. So with the kubectl, we can create, obtain, describe, or eliminate any resources that Kubernetes manages, such as pods, replica controllers, and services. And finally, the resource files YAML and JSON are used to manage and create pods. Please make sure to subscribe my channel for more free coding courses.